Hello, and welcome to this tutorial where we'll solve a fluid mechanics problem often encountered in professional engineering exams. Today, we're calculating the friction factor in a turbulent flow scenario in a concrete pipe. To recap, we'll be using the following steps to solve this problem. 1. Identify the problem and collect data. 2. Select an equation and ensure unit consistency. 3. Perform calculations and verify results. The problem states a fully turbulent flow of 20 CFS occurs in a 24-inch diameter concrete pipe. The head loss measured over a 1,050-foot pipe segment is 7 foot. In this example, we'll be determining the friction factor of the given pipe segment. Our first step is to confirm we're dealing with a flow within a closed conduit, which is true as it's a concrete pipe. Now, let's look at the given data. The flow rate, Q, is 20 cubic feet per second. The pipe diameter, D, is 24 inches. The pipe length, L, is 1,050 feet. The head loss, HF, is 7 feet. The acceleration due to gravity, G, is 32.2 feet per second squared. Next, we convert the diameter from inches to feet. So, 24 inches becomes 2 feet. Now, even though we usually calculate the Reynolds number to determine the flow regime, in this case, we're already informed it's fully turbulent. We'll now use the Darcy-Weisbach equation. This equation links the head loss to the friction factor. It's written as head loss equals friction factor times length over diameter times velocity squared over 2 times gravity. First, let's calculate the cross-sectional area, A, of the pipe. It's pi times diameter squared over 4. For our pipe, this equals 3.14 square feet. Next, we find the velocity, V, of the flow, which is flow rate divided by area. This gives us a velocity of 6.37 feet per second. Finally, let's solve for the friction factor, F, which is 2 times head loss, times gravity divided by length times velocity squared times diameter. Plugging in our values, the friction factor comes out to approximately 0.0212. To conclude, the friction factor for this turbulent flow in a concrete pipe is about 0.0212. This type of calculation is crucial in fluid flow design and analysis, especially for the professional engineering exam.